Hello, welcome to the 12th video in the series going through the 2019 AP Calculus AB Term 1 Standard Quiz Model. This time we're going to be attacking the first of the calculator section questions. I asked you to do a little bit of basic analysis on the graphing calculator. Basically in this question number 12, you're going to use the calculator itself to identify any of the following pieces: maxima, minima, zeros, regions where the function is positive, negative, increasing or decreasing, or possibly a little bit of both. So we've got a little bit of all those things mixed in there. So for this first one, for question 12 on the standard quiz model, I've given just a single function for simplicity, as well as to save a little bit of time as I'm making these solutions and videos. And basically you're given a polynomial function, so one that you could do some basic analysis on without a calculator, but one where it might be difficult to factor or solve without a calculator. So for this function, we've got a degree 4 positive quartic polynomial, and the first thing we're asked to do is to find the x-coordinate of each relative maximum of f of x. So we're looking for relative maximum, or maxima. We know that relative maxima are where the graph changes from increasing to decreasing, so we're going to be looking for places where that happens on the actual graph. So to help me here, I don't have a graphing calculator that I can easily show on this little webcam. So instead what I've done is I've downloaded an emulator, and we're going to go on and play with it. So this is a TI-84 plus CE graphing calculator. It's just been broken down into an emulator form. So what we're going to start with is first we need to make sure we're in the correct mode here. Our mode should be in radian mode, and it looks like in fact we are in radian mode, so we're in good shape there. So I'm going to go up into y equals, and I'm going to input the equation of our function that we're analyzing. So that's going to be x to the fourth, and sorry, it's kind of tough to see this. It's going to be x to the fourth plus 2x cubed minus 19x squared. And as we get ready to put all this stuff in the calculator, I'll point out that I'm just going to graph it on the standard window. It may or may not be a good call. It may require us to do a little bit more stuff. I'm a little suspicious that it might be because we've got a plus 12. We're going to go ahead and just zoom 6 graph this thing, and let's see what happens. So we can see some stuff in here. It's not the worst, but I noticed that it looks like there may be some relative minima down there. There may also be one down there, and we can also see the relative maximum. And that's actually important because we're looking for the relative maximum. So in order to do this, I'm going to need to change my window a little bit. So as far as side to side, it looked like we were pretty good left to right. I mean, there's our graph. Looks like we're not missing anything here. So instead what I'm going to do is I'm just going to change the y coordinates. So my y min, I'm going to make my y min, let's say negative 50. I'm just guessing here. I'm going to make my y max, let's go 25. And then for the scale, that just tells you how far apart the things are spaced. I'm just going to go every 5. And let's see if this does it. So again, all I'm doing is adjusting the window, trying to find a good picture. Notice we still don't have that low point, and because we might need it soon, I'm going to go ahead and make another adjustment. I'm going to go down to negative 200. It's just kind of a guess that might work. And there we go, look at that. We got a nice clear picture of our graph itself. So in our case though, we're looking for a relative maximum. So there's only one. I see one relative maximum right up there around the y-intercept, but not quite. So to get there, we're going to use the second trace menu. We're going to go to that Whittler button up there. We're going to go to the maximum option. And then we need to be to both the left and the right of that maximum point. And so now normally you were probably originally taught that you can just move these little arrows side to side. Truthfully, if you want to, you can actually just type in x values and do it that way. So I'm going to say that I want our left boundary to be negative 1, and I want our right boundary to be 2. Then it's going to ask me to guess. At this point, I'll just throw it in there. Looks like my maximum is somewhere up there. Press enter, and it very quickly, this is a really fast calculator, very quickly tells me that the x-coordinate of that maximum is 0.219. So there is our x-coordinate. And I will point out, by the way, that it does in fact say x-coordinate. It doesn't say the ordered pair. So if you put the ordered pair in this case, you would be incorrect. So there's our first one. We found the x-coordinate really fast. Nice little addition of using numbers rather than toggling with the arrows. Okay, the second question on here asks us to find the x values for which f of x is positive. So in looking here, the positivity, I can kind of see, hopefully you can see my mouse. It looks like there's a positive area over here on the left. Then we've got a positive area in the very center. And then we've got a positive area at the very far right. So just so we know, in order to get the positive area, we're going to need to find the zeros for this function. So we're going to need to do a little bit of work with our graph. And it's worth kind of doing a little sketch here, just to kind of help us illustrate what's there. It looks like we've got something that looks a little bit like this. Is that pretty accurate? Is that fairly close? Yeah, it's not the best, but it's close enough. So what we're going to need is we're going to need to find that one, that one, that one, and that one. So as you can probably tell, this isn't a perfect standard quiz question because it wouldn't ask you to find so many zeros. But we'll play along for the moment. So looking here, we need to go back to the second trace. We need to calculate zeros. So as far as values, I'm going to go with the first one on the far left from -8 to let's go -2. And then let's guess that it happens at -5. Okay, and it tells us that that first zero is going to be, -5.588. And of course we would accept the truncated version, -5.587 as well, but we're covering that first option. We need to get the second one, so we're going to repeat that motion. I'm going to go from -2 to 0. Let's go to -1. Looks like our second zero is going to be -0.602. So there's our second zero. So it looks like my picture was slightly off, but I know how to fix that. You'll never know. Ha 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 ha. Look at that. Okay, we need our third zero. You can tell, again, this is very tedious. Again, the questions for the actual standard quiz would not be so tedious. We're going to go, it looks like, from 0 to 2. Oops, sorry. 2. Guess that it occurs at 1. Tells us our 0 is 1.190. And then finally, we need one more. And then we'll finally be done with this misery. So for this last zero, I'll do it the old-fashioned way. I'll choose my left bound, choose my right bound, and then guess my value right in the middle. And it tells us that last zero is literally at 3. So it's nice for us to know. We now have our 4 zeros. All that's left for us is to actually go through and identify what the regions are. We have the choice of using this in interval notation or in inequality notation. For simplicity, I'm going to do this in interval notation. So for our particular question, we're going to first have the region right here, which goes from -infinity to -5.588. We're then going to have the region in the middle, which runs from -0.602 to 1.190. And then finally, we're going to have the region on the far right, which is going to run from 3 to infinity. So it turns out there are 3 regions, 3 intervals where the value of f(x) is positive. My goal in the standard quiz would be to limit that to no more than 2, but here we are. So there's our second one. Again, using our graphing calculator, that second trace button, really, really powerful stuff. Okay, third, we want to find all x values for which f of x is decreasing. Now we drew our picture up here, so I'm going to go ahead and steal it. That is my name after all. So I'm going to steal the picture. Let's get rid of some of this like fuzzy stuff. There we go. So there's our graph. We now want to find where f of x is decreasing. So for decreasing, we're going to need to deal with that section, and that's it. So there are 2 sections. The other nice thing here is that we do already know one of these important values, because basically from decreasing here, I can already kind of predict. Our decreasing is going to be from -infinity to that minimum value right there. And then second, it's going to be from that top value. And that top value, we know from the very beginning. That relative maximum occurs at 0.219. So it's going to be from 0.219 down to the other minima. So basically our job here, in order to finish this off, is we need to find the 2 relative minima, or the x-coordinates of the 2 relative minima. So let's do that. So playing a familiar game, second trace, we're going to go to minima this time. And let's see, let's first go to -5, -1. We'll guess it occurs at -3. And it tells me that minimum occurs at -3.9999998. Well, I'm going to just go ahead and assume that that is -4 0.000. You could also write -4. I'm guessing it probably is. But there is our minimum itself. It occurs at x equals -4, so we can throw that in there. And then second, we can go back and do a second trace one more time and get the minimum on the right side. That minimum is going to be somewhere between 1 and 5. And I'm going to guess that it occurs at 2. That minimum occurs at 2.28 excuse me, 2.281. 2.281. And there are our two intervals. So voila, decreasing comes out really cleanly. Now to finish this thing off, for this question, we ask you to find all x values where f of x is both negative and increasing. So that can be one where it can be a little bit challenging because you do have to find a couple different things, but I actually don't think it's going to end up causing any sort of issue for us here. So let's go through and use the information we've already found here and actually identify it. So we want f to be negative and increasing. That's going to occur right there as well as right there. So since we already found these values, it's not going to be hard to find the actual intervals themselves. So the first one runs from the relative minimum to that second 0. So going on to the previous page, that minimum was at -4. The 0 was at -0.602. That gets us our first interval. Our second interval is going to be from the second relative minimum. I think it was 2.287. Oh, 2.281. And then the 0 itself at the far end was, I want to say 3, but let's make sure. It was indeed 3. And so there it was. And so there are our two intervals where f is both negative and increasing. Works out really cleanly. So that covers our first of the calculator section. Pretty straightforward one to attack with, but you've seen it in action.